Hello.
Hello.
Good afternoon, sir.
Good afternoon.
Okay. Yeah, you can share the PPT and start the session.
Okay, thank you. Hello. Hello. Hello.
Yes, sir.
So we can start now, right?
Yes, yes.
So today our topic is in the one of the very critical, we can say, measuring principle for flow measurement, especially for acidic plant, highly corrosive material, gases, high pressure steam. So if you see the industrial systems where flow measurements are of different types, DP types, rotameter, magnetic, voltage, ultrasonic, and mass. Out of this magnetic, ultrasonic, and mass, voltage also critical, but these three are more having I mean, critical application, we can say, where non-contact type measurement or highly corrosive products are measured. So today we will see the electronic flow meter, and this is the flow meter is based on Faraday's law of induction. You have studied from I think eighth onwards Faraday's law, and that principle is implemented for measurement of the acidic fluid in the chemical industries. If you see here, the operating principle of magnetic flow meter system is based on Faraday's law. Faraday's law of electromagnetic induction, which states that a voltage will be induced in a conductor. Uh, if you must have studied this. Induced in the conductor moving through the magnetic coil. So in the picture you can see this is the coil shape. Magnetic field is generated through this magnet. You see these are the yellow lines are the magnetic fields, and the conductor you can see this one is moving. So uh, induced EMF is generated, and that induced EMF is measured here. You can see in this on this point. So Faraday's law, you can see here, E voltage induced is the constant BdV. So what are that E, K, B, dV parameters that you can see in the next slide here? Uh, the magnitude of the induced voltage E, this was, is directly proportional to the velocity of the conductor. This is the velocity. Conductor width is conductor width is d, and the strength of the magnetic field across this is a b. So you got a b d v. And if you see the relationship between the physical component and the magnetic field, k is a constant. So E is directly proportional to the one factor is the velocity of the conductor, and same is used for measuring the flow. So you can see here velocity is measured, and this velocity is then converted into the flow by giving a direct relationship with the EMF generated, induced EMF generated here. So this way it is a law is there, and this basic principle is adapted, implemented by various manufacturers in the instrumentation field, and you'll get a magnetic flow meter for industry ready for measurements. So if you see the picture of the flow meter here, in this one picture is shown. I will show you actual picture also, but you can see the pipeline, flanges, and this is the some cut portion where you can see the coil here, and here the sensors are there inside. You can see one, and this side sensors are there, which induces voltage is measured through these electrodes. These are the electrodes here. You can see here there are 2 points are there inside this, and through that you can see here voltage E at this one side and E at this side. So you'll get a plus minus or E induced voltage across these two electrodes. And you see this is the velocity, means your flow, fluid flow, which is a conducting. That is the property. It has to be conducting material. So acid is a conducting material, so it is passing through this pipeline path you see here, and induce magnetic field through these coils. This side also coil is there. So magnetic field is generated, which is here factor, E is equal to bkd. So B is a magnetic field here, and diameter means the diameter of the pipe is the diameter of the conductor. Diameter of the pipe is the diameter of the conductor. So magnetic coils placed on opposite side. Opposite side means this side and this side of the pipe in the magnetic field. One side cut portion is shown to you. As the conducting process liquid, means the liquid passes through like this, moves through the field, moves through the field means magnetic field generated by this uh, magnetic field generated by these coils across the pipeline. As the conducting fluid process liquid moves through the field with average velocity v, electrodes are told one side here, one electrode, another side here, and E is shown now. Across that the connection is there. Outside you get a two wire, and that wire connected for the further electronics processing on the transmitter here. I will show you the transmitter. Hmm. As the conducting uh, the electrode sends the induced voltage. The width of the conductor is represented by the distance between the electrode. Means conductor width, I told the diameter of this is the width of the conductor, or a distance between these two electrodes. Means one side electrode here, other is this side. So the distance between this is nothing but your diameter, d factor. So as you know here, you have a d, you have a fixed magnetic field through 110 volts supply, and then induced voltage across the electrode you are measuring here, and v is the what the processing fluid, and passing through this is your velocity of the conductor, this. So velocity v here shown, E is measured. This is the d diameter, and magnetic field is across. This is here. So you can see here, inside portion is having insulation because it is a corrosive material. So highly corrosive, we can say acid, nitric acid, sulfuric acid, formic acid. So these acids are acid lines. It is used. So you can see here an insulating liner prevent the signal from shortening to the pipe wall. So the pipe material is steel, carbon steel, or you can say metal, and short circuit should not happen. Therefore, the lining is there. The Teflon lining is there, white color. So that insulation as well as corrosion. The only variable in the application of Faraday's law is the velocity of the conducting fluid V. Other parameters, your magnetic field is constant, distance is constant. So you can see here, because the field strength is a controlled constant and electrode spacing is a fixed. Therefore, the output voltage generated here is directly proportional to the liquid velocity. So our interest is the velocity, flow rate, so velocity, resulting in the linear output of the magnetic flow meter. This is very important. So this uh, equation you can see is a linear equation because E is directly proportional to velocity of the fluid, because E k is a constant, B is a constant, and D is also constant here, and therefore this is the principle used for measurement of a flow rate. Means this is a magnetic flow meter. Mm. So you have seen the construction also, cut portion here, electrode connection, coil, inside portion of the pipe. So Crony Marshall, earlier it was a Jane Marshall, earlier we call as a Force Marshall also. So this is the company is in manufacturing in Pune, Mumbai Road. They have very nice factory, Force Marshall, and they manufacture. Crony is their uh, Force Marshall is a big group, and in that Crony uh, is a very popular or a reputed manufacturer in the magnetic flow meter measurement in instrumentation. So that Crony company is under the Force Marshall group. That is all. So therefore, Crony Marshall. So this is the, as I told you, it is manufactured in Pune, in Mumbai Pune road factory is there. Old Mumbai Pune road I am talking. Near between Chinswad and we can say after Shivaji Nagar. Hmm. So you can see here, this is the one model K300 model, and just for your understanding, to understand the uh, specifications of the flow meter. So you can see here, we have discussed the control wall. There DN was there, which indicates the pipeline size. So you can see the meter size means the pipeline size, 3.5, 3 by 8, up to maximum 16 inches, and in millimeters also it is there, 10 to 100 meters. So that indicates the size of the meter. Power supply, as I told, it requires more power because you have a coil. It starts from 110, 170, 220, 240, because that requires more voltage for the coil to generate the induced EMF. Means I'm talking about these coil require 230 volt, for example, yeah, 110 volt, right? And you can see here, this is the junction box from where the wiring cabling is done. Only for purpose of uh, demonstration, the cut portion has been shown, but this cabling and all goes through this. Hmm. And you can see the accuracy between 20 to 100%, or plus minus 0.5% of measured value. So that much accuracy you will get for this particular model. And there are this is another scale, full scale or measured value, whatever you can have. Optional plus or minus means you just understand 0.5% of a measured value. Suppose that is the variation we can say. Means suppose you are measuring flow rate 60 liters, so it will be a 0.5 percent of deviation only in that percentage. So that much accurate I can say. So electrical conductivity, because conductivity is required for the that particular fluid flow. Without that, it will not principle will not, means the induced EMF will not generate. So therefore, electrical conductivity uh, either you can say greater or equal to 20 micro Siemens. This is unit of the conductivity. Full scale velocity and lining. Velocity, full scale velocity that depend on your size and your product. So it is not mentioned here, but you can say lining. As I told, it is a PTFE means Teflon and all we call as a white color Teflon. PTFE means Teflon and hard rubber or neutron. Optional is a rubber. So you can have a lining inside to get isolation, short circuit, as I told. And electrode material is a very special quality steel that is a hastolloy C, very special quality steel. Because as I told, if you see this meter, nothing is in contact metallic part except the electrode, small portion will be in the contact of the acid. And if the acid flows and this metallic part get corroded, so to avoid the corrosion, therefore this particular steel hastolloy C is not getting corroded due to the nitric acid or any strong acids. So that is why it is the electrode material is a very costly steel. This carbon steel that is hastolloy C. Optional is hastolloy B is another product. Monel is also used. Chromel, nickel, steel. So these there are options also, but commonly material is a hastolloy C. Hastolloy is the uh, one grade of a steel. Uh, that material hastolloy material is very used, and that is a acid resistance material. That is why. Then you can say tantalum, titanium, platinum, very costly materials. And we can say precision metals are used for the electrodes. Mounting is a flange. Mounting is a flange means if you see here, this is a portion is called a flange. A hole you can see now. So this side in the pipeline you can fit. So it is fitted in the flanges with the nut bolts. This side and this side you can see this flange nut bolt and here this side. So this is a basic specification of the any electromagnetic flow meter. What are the specific size, pipeline size, power supply requirement, accuracy, conductivity of your processing fluid flow, then lining, inside lining of the inside lining for protection and isolation from the electrical short circuit. And electrode material is also very important. And mounting is always it is a by default is a flange also most of this, because it is easy to install and remove for maintenance. So these are the basic specification of the this flow meter. Now we have covered the uh, basic principle, that is on Faraday's law, E is equal to bk dv. Then we seen the actual construction, the cut portion, what are the parts inside this, what type of material is used, how coil is installed, how electrode is installed, how the measurements is taken out, supply voltage, how it is terminated, and then we seen the specification also, basic specification of the magnetic flow meters, electromagnetic flow meters. So advantage of the flow meters, magnetic electromagnetic flow meter over the other flow meters are listed below. You can see accuracy wise is a good accuracy, can handle slurries and corrosive liquids. That is the plus point because there is no any obstacle in between. You have seen the electrode is almost slightly coming in contact with this. So even your corrosive slurries, highly acidic slurries, corrosive fluid, you can get a good accuracy or measurement also over the other meters. Because the other meters you can see most of the meters you either there is a some sensor or s- some parameters which come in contact and blocks the flow, and chances of choking in the case of slurries happens. But these as we use in this RCF in fertilizer like earlier we call it the sufla, which now stopped giving the name, but NPK we can say 15 15 15 or 20 20 D0. So there normally slurries are coming, acidic slurries, phosphoric acids and all or nitric acid are in the slurries. So to measure that, these meters are used. More meters are there. Magnetic flow meters gives a major advantage to the fertilizer industry. So low pressure drop, as there is a no obstacle in the pipe, so pressure drop is no. No obstruction in pipe that you have seen in the construction also. Or you can see again here, you can see straight away the path is there. Only you can see this electrode is not coming out also. It is in the line with the liner. So entire portion is very clear, and as it is a liner is there, so there is no chances of choking also. It will not stop the flow. Adapted for many materials. So you can see it is has a various types of materials, uh, chemical type you can measure. Bidirectional flow measurement possible. Again, because there is no this direction this you can use both the direction. Unaffected by visibility, unaffected by sorry viscosity, density, temperature or pressure. All these four parameters will not affect your measurement in the electronic flow meter because these parameters are not in coming in the measurement because only induced EMF is generated based on your magnetic field generated by coil and the measure your sensor means electrode. So this only the condition we have is your process fluid has to be conductive, slurry has to be conducting material, that's all. So irrespective of the viscosity, density, temperature, pressure, your measurement will not affect. So this is the biggest advantage. Can measure turbulent or laminar any flow. You can have a high speed, low speed. Turbulent means you can uh, means bubbles and all. If it is no issue, you can measure. So this way, a lot of advantages are there in this flow measurement, and therefore industry. This is the popular flow meter in the industry. So maximum usage is in the chemical, fertilizers, refineries. You'll find. So what are their limitations? We can say disadvantages, limitations. As I told, conductivity must be greater than 20 microohms or Siemens. As I told, your fluid has to be conducting. Then your meter must be full at all times. Means inside the meter area. I am talking about this. This is the meter area. This should be full and not like half it is going. So definitely the reading will be less, will not be correct. So it should complete the pipe full and across this. So you can see meter must be full at all times. Then relatively high cost. This is, as I told, it is the cost is high as compared to your DP, rotameters, and other Vortex. It has a lot. You have seen the how the sensor material, how costly, precise, precision metals are used. High voltage is there. So because of that, relatively high cost. Inline mounting required. And again, we can say limitation means you have to break the pipe, and within the pipe using flange you have to mount. You That is the what very important, because why it is a disadvantage, because when you are removing or fitting back, you have to take a care whether leakage should not be happen, and accident should not be happen. To you how to properly isolate the pipelines, so that your staff should ensure all standard safe operating procedure while calibrating, while mounting, installing, or removing from the line. So that is a limitation. Inline mounting required, and electronic fouling occurs. So again, suppose your electrode get damaged, so naturally fouling occurs. So that you have to remove and clean properly. If it is damaged, you replace new electrode. Like this, you have to do maintenance. So these are the limitations, or we can say disadvantage of electronic flow meters. Hello, 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 hello. Am I audible? Hello, hello, hello. हेलो.
सर येतोय आवाज.
हाँ येतोय. हाँ ठीक. So in this slide, you can see here one plant where electronic magnetic flow meter is installed here. You see here a very small pipeline, but you see here how it is installed. And here I will demonstrate the flange connection, and inline mounting means this is the mounting here. And these are the flanges. You can see pipeline side this flange, two flanges, upstream and downstream. This is the what arrow direction has shown. Uh, and because flow is going like this is the water flow, water is also conducting, so we can use this. So you see here, uh, these are the flanges of the magnetic flow meter body. This is a magnetic flow meter entire thing. You see here, uh, uh, earth for earthing, proper earthing is done because it is connected to the pipeline. As I told, it requires 110 volts AC voltage. So the current should not flow in the pipe because pipe is also conducting. Therefore earthing is taken here, and you see here the cablings are here on the top, and the signal generated, signal sensed by electrode is also taken to the transmitter. So you can see the transmitter is also mounted here. You see here, it is attached here transmitter, and that transmitter indicates you the actual real-time flow. You can configure this for any unit, liters per hour, meter cube per hour, and the output of this transmitter is a 4 to 20 milliampere, which goes to the heart output, goes to the DCS side from here. from this cable. So the way it is installed, you can see here how magnetic flow meter is here. Similarly, on this plant, you can see here other instruments also. So you can see what is this? Anybody? You can see here for measurement of this water temperature here is RTD. Say or sometimes we can use thermocouple also on top. Only why this elbow is more, because the pipe is very small, so contact portion to the RTD or thermocouple will be less. Therefore, this portion is created for getting reading. This way, elbow is added bigger diameter at this point or here also. That is the reason. If you want to measure the temperature on very small pipeline, it is difficult to insert the thermocouple or RTD. So to get this reading, you the this area is this type of elbows are welded here, and you can see here one more meter here is a rotameter type. This is a rotameter transmitter. Rotameter on this is a magnetic type principle, not like a float. Is a magnetic type principle based rotameter here. And then other instruments you can see here wireless temperature transmitter here. You see here this is a wireless temperature transmitter, and this temperature transmitter is getting input from this RTD. This is connected here, and this reading whatever transmitter has the LCD here display, but then the signal of the transmitter is collected at the gateway here, and this gateway is connected to DCS. So next, I think semester you have DCS, so you will come to know. But as wireless transmitter is a normal transmitter here. There are RTD, thermocouple, and our today's topic is a magnetic flow meter. And this one equipment is a heat exchanger. This is the heat exchanger. These here you can see that all your power supplies going to the various instruments like this instruments coil required 110 volt, so it will be coming from here. So basically this is the heat exchanger plant with cold water here and hot water here. So cold water is going to the heat exchanger, and then goes out, and hot water from this tank is coming at the shell side, and sorry, tube side, and shell side is the cold water. So temperature is measured because in heat exchanger you will get suppose hot water inlet has suppose ambient temperature 30 degree, so you'll be get more temperature at this point when you measure the output. You can see this is the input side measurement, the output is the measurement is here, so somewhere it will be other side. This is the input side. You can see small pipeline coming from here. It's a tube side measurement. So you can have tube and shell type of heat exchanger here. So anyway, I explained this other part because you should not see what is the process. So it is a heat exchanger plant. Heat is exchanged by cold water. Sorry, heat is gained by cold water and lost by hot water. This is the energy balance relations, mass energy balance. Hmm. So in this picture, it is a clear now. You see here, I am talking about this magnetic flow meter, this one, right? This one. Again, this is more clear. You see here, display. This is a transmitter portion. This can you replace? This is your actual mounted on the pipeline. From here, you'll get a supply from here. Either it is embedded or you can have a separate uh, location for transmitters. But most of the cases is embedded. Means on the same body it is there. You see here. This way, this is the what it is mounted. You see now it's very clear. These are the flanges with a nut bolt, and these are the flanges of this magnetic flow meter body. You see here these nut bolts, and inside that this is gaskets. You see, and this is earthing. This is what in the pipeline. This is the pipeline, and a rear side transmitter like this display will be that side, right? So this is what you have seen. This side is this portion where you have electrode connection. Means electrode measures the induced voltage. Then some connection goes to the coils, right? So this is what the installation of the transmitters. Now, how to calibrate or simulate the magnetic flow meter? So nowadays, it is a simple. There are two parts. As you see, as I told, this is the body of the control. You see the plunge. One side I have closed here. Therefore, you can see there is no path here. But because you have to fill the water inside to calibrate it. As I told, it should be filled. Then only you will get a reading. And this is earthing connection. And coils connections are coming like this. You see here, coil connections inside goes to the coils are here. And normally, even though we say bidirectional, but you see the arrow is showing a directional flow. You can flow should be this direction. Then this is the transmitter portion, right? And whatever transmitter means, you can see here the electrode wires are coming and connected inside the transmitter, and 110 volt supply goes to the or 230 volt based on the coil you are providing here. And you see this is the simulator. uh, Simulator means as you know the you have to calibrate the flow. So actually sensor calibration is one part, and means inside the sensor whether they are sensing properly. If suppose it is a full of water, so it's a steady flow. So steady flow means some reading has to be shown here. And when the conductor is moving, velocity is increasing, then your reading will be. So at least you can have uh, zero reading here, steady flow, or of your zero and span. So zero you can get it here because you are fully conducting here with the full of water. So this is the one part. Normally, it is tested or calibrated in the flow lab where pipeline is created. Two tanks are there, and then uh, this in this picture you have seen. This type of a setup is there. Here, like this setup, we fit it there, and we measure through the tank, a meter tank. That tank is a metered. Metered means uh, flow liters per hour or meter cube per hour, how much tank flow has come. So we calculate it, and whether same is noted by these sensors, that way calibrated for the sensors. But in the lab, whether sensor is working or not, that you can test. One side you close it and fill it with the water, make it a reverse way so that water will be there, will be steady. Means you can stand on this, right? And then you can get reading here. That means your electrons are working. Or then electronics of this transmitter, transmitter calibration can be done through this simulator. Suppose your range is 0 to 100 liters per hour, for example. So 0 is 100, uh, s- uh, 0 liters per hour is 0, and span is 100 liters per hour. So here you have a knob. Through that you can create signal for 0 and feed it to the transmitter electronics. That time transmitter should show here 0, right? There are some buttons also here in this crony. Through that it is also possible, but that procedure needs practice and manual. Some push buttons, one, two, three times like this, push buttons use, and through that you can calibrate. But nowadays these simulators are available, and only thing these simulators are very costly. Uh, When we purchase for us that time it was more than 2 lakhs, especially for this simulator. And this entire product came around 5 lakhs. So as I told, it is a costly as compared to the other flow meters, but it is a worth. And as I told, because as long as your corrosive product, you have to measure to your plant process, existing process. So quality also depends on measurement. So that quality, optimization, and maintenance also. You can say other meters will fail. Every time you have to change, plant will stop. So it is a worth. I am telling you. So what is here? This is the main body of the flow sensor here, where the coils are there. Inside the, you can see teflon portion looking like that. Then earthing plates are there. Then electrodes are inside this, which are mounted at this side and that side, and internally you will get a connection from here. And this is a transmitter, and this is the transmitter simulator. I'm not talking about the electrode simulator. Electrode simulator is done in the flow lab, especially designed for various size of the flow meters. Means as I told, 1 inch pipe, 2 inch pipe, 3 inch or 4 inch, as per DN size. Flow caliber means a particular organization mm, develops their setups, or sometimes they send it to the uh, labs, outside labs, where they only do the testing calibration of your fluid. So you have to send there and calibrate it. So as far as IDMI in Mumbai, or there are so many labs now in the Navi Mumbai and all, which are accredited labs. From there you have to take a certificate and get it tested. So that is also the facilities available everywhere nowadays. So this is the Crony products, as I told. So this is what about calibration setup, calibration procedures. Yeah, here in this slide you can see the display also. You can see here, and slightly you can see the how the range, and here this you can select from these knobs. Mm. So that's all about flow meter here. If you have a question, we'll address now. Hello, any question? Hello. So as I told, flow head. This is called a flow head, transmitter, and simulator. You see the wiring here. Actually, this part is mounted on here. Presently, it is removed for understanding purpose or calibration purpose. But uh, the pipeline you are connecting here, and this transmitter will be on this. This you can see your connection here and here. It is connected, and then it looks like this way. Like this. You see here. It looks like, so connections are here. It is like this. Mm, mm. Hello, 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 hello. Any question?
Yes, sir.
Any
One
question?
minute.
This slide is indicating the simulation of the transmitter, testing of the electrode setup in the lab, where you can see again. I'm writing this is the simulator, which can give you different ranges.
Hello.
This is the transmitter. And this is the what flow meter sensors and body, where you can see the wire 100 230 volt for a coil and electrode signal coming from here. And this transmitter you can is mounted in the field on this top of this, and the on the pipeline this way transmitter looks like. So orientation is possible as per a user requirement. There is no issue. So this is about the electromagnetic flow meter uh, ap- for your starting of the career. Later on, you can learn furthermore about the, as I told, how it is maintained. And mostly in the process plant, what happens? Suppose plant name is nitric acid, or plant name is any fertilizer, NPK fertilizer. So the people are busy in the plant. If the flow meter is not working, they understood the readings are not as per their process requirement, then they remove from the line and send it to the instrumentation workshop. And these setups are available in instrument workshops, and that I am demonstrating here. So what are the setups required for calibrating transmitter? This simulator is required for testing purpose of the electrode. One side it is closed and it is filled with full water, and electrode whether it is sensing the zero, that is tested. So electrode is tested. If it is not, then electrode is also replaced, or any wiring damage inside it will be rectified. And actual full range, suppose that is 100 liters per hour range is there, it is tested on the flow uh, setup, where actual tanks are there with the calibrated tanks, we can say. So in 1 hour 100 liters is uh, coming down from the tank, then another tank it is showing 100 liters there, then meter whether showing that same. So you can see it is like a physically we are checking it. And mostly that labs are available outsource lab, I mean certified accredited lab outside, they do these jobs. But as our RCF is having a lot of flow meters, more than 300 400 flow meters, so we have as per our size, we developed in our workshop flow labs. For few meters which are very higher size, that goes to the outside. But most of the meters we calibrated, tested it in our flow lab. That's all. So that's all for today. Any question?
Uh, no question, sir.
Thank you. So can I close now?
Yes, yes, sir. You can close.
Okay. Thank you very much. Madam, afternoon tea any session? Hello?